Hi, welcome to my video on the inverse trig functions, and this video is on the arc tangent, so it's the inverse of tan. And as in previous videos, let's look at the unit circle whose radius is 1. So as we rotate around this circle at 0 degrees, x is 1, y is 0, and at 90, x is 0, y is 1, and at 180, which is the rotation here, x is negative 1, y is 0, and at 270, x is 0, y is negative 1, and back to 360, x is 0, and x is 1, y is 0. And let's look at the graph of y equals tan theta. Tan is the opposite over adjacent, which is the sine of theta over the cos of theta. And tan is undefined, so when you have cos theta equal to 0, and you have 0 in the denominator of your fraction, it becomes undefined. So cos is 0, cos is the x, so that means that x equals 0 at your 90 and 270, etc. Or it could be negative 90, negative 270. So tan is when theta is 90, tan is undefined. When theta is 270, tan is undefined. When theta is a negative 90, which is here, negative 90, tan is undefined. And you can see that tan is undefined at multiples of 90. So 90 plus 180, which is the period of tan. So tan is undefined at all these locations of 90, 270, negative 90, negative 270. Tan, as you recall, comes down here and does this. So the period of tan is 180. So the tan of 0 is the sine of 0 degrees is 0. The cos of 0 is 1, so the tan of 0 degrees is 0. So the tan graph repeats itself like this. And we come down, it goes through negative 180. So there's the tan graph repeating itself over and over and over. So we have to find the inverse of it. And again, when we draw a horizontal line, it passes through many points in the tan graph, so therefore its inverse does not have a function unless you restrict the domain. So what they do, they have agreed many years ago, agreed to restrict the tan at 90 and negative 90. So they're going to look at all the degrees between negative 90 and 90. So they're looking at this piece. This is the piece with the restriction. So that means that your domain is the values of theta is between negative 90 and 90. So it's 90 less than theta less than 90 degrees. Notice there's no equal sign because this is an asymptote, vertical asymptote, so there's no equal to. And the range is the set of all real numbers, because it goes, the closer and closer you get to 90, the higher this number becomes towards positive infinity. The closer this gets to negative 90, it goes to negative infinity. So the range is all the values of y. And so if this is your graph of your restriction, then we have to, its inverse is switched. So your domain becomes your range. So your range is real numbers, so your domain is the real numbers. Your domain is negative 90 to a 90, so your range is negative 90 to a 90. So that means that your range is your, if you think of it in relation to theta, it's 90 is here, and this is negative 90. So if there's asymptotes, if this is vertical asymptotes, then these will be horizontal asymptotes, like this. And the horizontal asymptote will be at the 90 and the negative 90. So this graph, again, if you take this graph here and do the 45, the tan of 45 is 1. The tan of negative 45, which is right here, is negative 1. So if this goes to infinity, it goes to 0. So the tan of 0 is 0. So this graph goes like this, comes through, and goes like this. Now, again, when you take a 45, you get a 1, which is right here. Let's say this is restricted. This is 1, 2, 3. This is negative 1, negative 2. So when you have 45, instead of that dot there, it'll be right here. And at negative 45, it'll be right here. So that tells you. But another way to do that I developed to help understand is that I took this graph, and let me explain. This is the graph of this restriction. So if I take this graph and do reflection in the line, so if I take the line that moves up through the middle, because it's reflected in this line right through the middle. So it was reflected in this line going up through the middle right here. Then the reflection, watch, I'm going to put my fingers on the graph, and I'm going to reflect it so that my ends of my thumb are the ends of this line going to the middle. So when I reflect it, there it is, I'm reflecting it over, it becomes, so this graph is the reflection, and there it is there. So this point right here is 145 degrees. This point right here, y is negative 1, I said x, my mistake, and negative 45. So that's how I do to show the reflection. You flip it over like that. Just a little trick I've learned when I was teaching. So let's do more. So remember that the inverse of the y equals tan. Now notice what I have here is the graph of y equals tan theta, and I have it from negative 90 to a 90. Notice the brackets are open brackets, negative 90 to a 90. So you say, well, why haven't I shown the inverse? Well, if I know where it is before I reflect it, then I know that looking at this graph, which is not easier than the inverse, but between 0 and 90, if you take any value of y that's positive, then the angle got to be between 0 and 90. If you take any value of y which is negative, which is going down here, then the value of theta got to be between 0 and negative 90. So tan is defined between negative 90 and 90. So when it's positive, it's between 0 and 90. When it's negative, it's between 0 and negative 90. So let's do some practice to illustrate that again. Tan of 225, so there's 0. So 225 is 180 and 45 more. So that's 225 degree rotation, right around right to here. So you draw a terminal arm. So if this is 180 degrees, then this is a 45 degree on this arc. So that means this angle is 45, and this angle in the right triangle is 45. So this is a 45 right triangle. So the sides are 1, 1, root 2. The x is negative in the third quadrant. The y is negative in the third quadrant. So the tan is the opposite over the adjacent. So it's negative 1 over negative 1. So the tan is 1 in the third quadrant. Remember, add sugar to coffee. Everything is positive in quadrant 1. Sine is positive in 2, tan is positive in 3, and cos is positive in 4. So tan is positive in 1 and 3. So what about, let's look at the angle negative 215. Start here, negative 215 is right around right to here. Sorry, negative 315. So there's negative 315 starting here, right on around. So we drop a perpendicular to the x-axis, so that's a negative 315. That means this angle here is 45. This angle is 45. So this is a 1, and a root 2. So in this quadrant 1, the x is positive, the y is positive. So again, the tan is sine 1 over 1. Tan is the opposite over the adjacent, 1 over 1, and 1 over 1 is 1. So notice in these quadrants, the tan of, because the reference angle is 45, the tan is 1, because tan is positive first and third, and it's the sides are the same length, so we get a 1. What about the inverse of tan? So when we look at the inverse of tan, I'm looking at this restriction here. So if the inverse of tan, the arc tan of 1 is right here. 1 is right here. So the arc tan, 1 is here. So that means the angle is right here. If you drop a perpendicular down here, so the angle is right here. So that means the angle must be between 0 and 90. So the arc tan of 1 is 45 degrees. But these angles here, you get a 1 to 1. But I can't pick 225. I can't pick negative 315. I have to pick a positive angle between 0 and 90. And the positive angle between 0 and 90 is the 45 degree angle, because it has to be between 0 and 90. So it's a 45. Or in radians, 45 degrees times pi over 180. 45 goes into 180 4 times, so we could have a pi over 4. Let's look at the tan of 120. So there's a 0, that's a 90, 120. So let's say this is the tan. This is the rotation of 120 degrees right to here. Drop the terminal arm. Terminal arm goes through the point. Drop a perpendicular. And if this is 120 degrees from here to here, this is 180. That means this arc right here is 60 to make up the 180. Central angles are equal, so that's a 60. I have a 30, 60, 90 right triangle. And opposite to 30 is 1. Opposite to 60 is root 3. Opposite the hypotenuse is 2. In this quadrant, the x is negative and the y is positive. So the tan is of the 120 is the tan of 60. So its tan is the opposite over adjacent. And so it's in relation to the reference angle. Opposite is a root 3. Adjacent is negative 1. So that's negative root 3. Well, what about if we do the tan of 300? The tan of 300 is all the way around till we get to, that's 270. 300, let's say, is right here. So that's a 300 degree rotation. Terminal arm going through this point, perpendicular drawn. So if that's a 300 degree rotation to here, that means this arc right here is 60. So that means the central angle is 60. This is the 30. Opposite 30 is 1. Opposite 60 is root 3. Hypotenuse is 2. In this fourth quadrant, the x is positive, the y is negative. And again, the tan is the opposite over the adjacent in relation to the reference angle of 60. So it's a negative root 3 over 1, which is negative root 3. So what about the arctan? The arctan of a negative number. This is the restrictions before I did its inverse. So I'm looking at this, which makes it a little bit clearer if you think about it. The negative root 3 is, this number is negative here. So negative root 3, if you do the square root of 3, you get what? Just look at the square root of 3. Turn on the calculator, and we'll do the square root of 3. So the square root of 3 is 1.73. So the square root of 3 is, this is a negative 1.73. So there's a negative 1. So it's about here. So that means this angle is somewhere between 0 and a negative 90. So it's a negative angle. So to get the negative root 3, I have to be in this quadrant, but it has to be negative. This triangle is perfect. And the root 3 is the tan because it's opposite over adjacent. So it has to be a negative 60. It got to be between 0 and 90. So if it's in this quadrant, it has to be a negative 60. And again, a negative 60 times pi over 180. 60 goes into 383 times, so that's a negative pi over 3. So in degrees, it's a negative 60, and in radians, it's negative pi over 3. So just to illustrate that, let's do the arctan of a negative root 3. Here we go with the calculator. We'll clear it, and we'll do inverse tan of a negative, and we'll do the square root of 3. And let's see. And we get, as you can see, we get the negative 60. Again, the calculator always works out in relation to the inverses. And we have a couple of more to do. What about arctan of negative 1? So again, here's the restrictions. Negative 1 is right here. So this is the angle. So this is negative 1. So what is the angle? So to get tan, negative 1 to 2 sides got to be the same. So it has to be a 45-degree right triangle. And the angle, to get a negative 1, which is right here, there's the angle got to be between 0 and 90. So it has to be negative 45. And again, negative 45 is a negative pi over 4. It's negative. Think about 180 divided by 4, you get a 45. And what about if we have the arctan to the negative 1 of root 3 over 3? Well, root 3 over 3 reminds me of a 30, 60, 90 right triangle. Okay, let's see. And root 3 over 3 is 1. Opposite 30 is 1, opposite 60 is root 3, opposite to 90 is 2. And this is a positive number. This is a positive number. So if this is a positive number, the number is positive right here, going upward. So that means the angle is here somewhere between 0 and 90. So that means it got to be in the first quadrant. So if I draw this triangle in the first quadrant and I need to get the tan is opposite over adjacent. So root 3 over 3 came from 1 divided by root 3, which is root 3 over 3. So that means we have tan is opposite, which is 1 over root 3. And so we have a 2. So if it's opposite over adjacent, 1 over root 3, which is root 3 over 3, that means this is a 30-degree angle. This is your 60. So in this quadrant, we have to have an angle between 0 and 90. So we have to have a 30-degree angle. And 30 degrees is 30 times pi over 180. 30 into 180 is 60. So 30 is the same as a pi over 6 in terms of a radian. So that's looking at the inverse function for tan. Just one of the ones that we do. And we got 3 done now. We got sine done, we got cos done, we got tan done. So I have 3 more to do. I have cot, secant, and cosecant. And again, if you like my video, click on the like button, click on the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.